Today we want to talk about data types. It's an important tool for good programming practices. In this video, we're going to recommend 4 articles that discuss the benefits of proper use of data types in programming. In case you don't know, data types are used to express an object's properties and constraints, including what values we can assign to it. For instance, if we want to express the concept of seasons, we would define a data type that offers a set of options, such as summer, autumn, winter, and spring. This prevents us from assigning an invalid value to seasons such as Tuesday, which is a day of the week, and allows the rest of the program to handle the data in a consistent and expected manner. Now, working with data types has its nuances. These are the articles that help me improve my understanding of them. The first article is Parse Don't Validate by Alexis King. It explains how to use data types to make your code simpler and more secure. She proposes to use data types that express incoming information and then validate and encode that information only once at the program's entry point. This eliminates the need for repeated validation in other functions and makes sure that the information is always in a valid state. For instance, when asking a user to input a season, instead of saying, I get an arbitrary text string and I need to check if it's spring, summer, winter, or autumn, you can parse the string at an input time by creating an object season with a proper value for each season, each being unique and distinct from all others. For example, the string spring would map to the unique value spring. If the input isn't a valid season, parsing will fail and return an error. But if it succeeds, you know for sure that the object is valid because its state is encoded in the data type. The second article, called No, Dynamic Type Systems Are Not Inherently More Open, also by Alexis King, is a response to criticisms of the first article. Some people criticized her proposal of validating incoming information using types because when the shape of the input data is not fully known, it may be more difficult to do this. King argues that both static and dynamic type programs will make the assumptions about the data shape. But with static types, you have to be explicit about these assumptions, which can help catch problems early on. For example, in an HTTP proxy, the payload could be any HTTP content. Headers may come and go, etc. We could just express the fields and headers we need and assume the rest to be an abstract payload, expressed as a mere array of bytes that will be moving around. The third article is Types as Axioms or Playing God with Static Types, again by Alexis King. Here, she explains how types can be used to build and prove that things are correct by construction, as well as how to compose types to create new ones. For example, in one of our cryptography projects called KairoRS, where we work with prime field arithmetics, we need to make sure that the elements of the field are always kept in the field during internal operations. Everything else in the program can assume that the number it receives is between 0 and the prime that bounds the field, but further, that by construction, any arithmetic operation between two field elements will also return a field element. If you didn't understand anything I just said, I also recommend checking out our blog posts about cryptography, which are linked in the comments. The fourth article was written by Joel Spolsky and is called Making Wrong Code Look Wrong. Spolsky is interested in the programmer's point of view, rather than the compiler's. He proposes using Hungarian notation, which is where you add a prefix to your variable and function names to show what type of data they contain. Basically, it makes it easier to see what's going on your code just by looking at it. Polsky also talks about the importance of making sure your inputs are clean and your program follows certain rules, so that it's easier for others to understand. It's not about static or dynamic typing, it's about making sure the code makes sense to a human being. In conclusion, these articles make the case that using data types effectively will help you work smarter and not harder. They'll let you think about your programs in terms of the information that they handle and making it easier to catch errors. Strong and static typing forces you to be more specific, reducing the chances of bugs and vulnerabilities. Overall, using types makes it easier to understand what your code is supposed to do. What I presented is just a summary. I encourage you to go and read the original articles because they are very well written. What is your take on types? Do you have any articles to recommend? Thanks for watching and I'll see you next time.